How's it going, everyone? My name is Carlos Garcia. I am the team captain of the East Los Angeles College Red Rock Rovers. I got something pretty cool for you guys today. I'm making a video that's going to go over some of the design elements of our craft. Before we get started, I want to say thank you to a couple of people. I want to say thank you to ELEC Engineering and Technologies for all the support that they've given us with our project. I also want to say thank you to Brian Vasquez of the East Los Angeles College Engineering Club, who's been super supportive with our cause, and also to East Los Angeles College SHIP. That's a Society of Hispanic Professional Engineers. And I definitely want to say thank you to everybody that's followed us on Facebook and on Twitter and on Instagram. I want to say thank you so much for your support. Hang in there, keep in touch with us, and we got some exciting stuff coming up, especially regarding to the event date and to the East Los Angeles College Red Rock Rover fundraiser concert. But let's go ahead and get started on this little video. Right here, let's start with this. We have an airfoil, a basic airfoil design that was designed by Alfonso Perez, one of our team members. He gave us this dimension right here that we inputted in a 2D plot in SolidWorks. So he basically just designed this aerodynamic design that's going to create lift. We then took that same dimension and made a wooden piece out of it. The piece itself is about 1/2 inch thick, so it's not significantly thick, but it is long. It's 4.5 feet long, so it runs 4.5 feet from here to here, this straight line. So it's a pretty long piece. To this piece, you're gonna see 2 cutouts right here, and that's where the wing spars go, and those are the supports that run the length of the wing or the wingspan of the wing, where these ribs are gonna be spaced out on. Right here we have a bracket, and this is an attack angle bracket that's incorporated into the design. The purpose of the bracket is to give the wing a certain angle. So I'll show you more of this in a little bit, but this is an attack angle bracket right here. This here's the fuselage. So this is the main body. As you can see, we have a very simple design, but the design itself is actually pretty big. It runs 20 feet from here all the way back here. So even though it seems pretty small, it's actually pretty long. This hole in here is big enough to hold our pilot Gabriel Garibay, and the rest of it is sort of designed just to keep the structure strong enough for our efforts. So that's the fuselage right here. These are the wing spars that I was talking about, which are these pipes that run the length of the wing itself, and we have a smaller tube in the back and a bigger tube in the front, and then they run the length of the wingspan, and then I think approximately every 2 feet we have a wing rib right here, which you see right here, sort of repeated often. This is one wing for one side, this is another wing for the other side of the craft, and this is what it looks like when it's all comes together. Here's that attack angle bracket, and the purpose of that bracket is to go ahead and give the wing this angle right here. So this angle right here was calculated by some of the team members to be an ideal angle to create the maximum amount of lift at a slow speed. So basically, this angle is pretty intentional. Something that we calculated over a few hours to make sure that we got right. The fuselage right there, as you can see, this is where the pilot's gonna go, right in here. And there are some elements still missing to this craft. There's some exterior elements that are sort of just a facade that's going to give the craft a certain look, but it has no real purpose in terms of the flight. The only thing that's missing in terms of flight is a control mechanism that's going to control a rear wing back here. And the reason the rear wing is not here yet is because we really haven't finished calculating where the center of gravity is going to go relative to the pilot. So for example, once the pilot is sitting in here, that center of gravity is going to shift up and down this craft. Once we know where that center of gravity is and where we want it to be, then we're going to incorporate that rear wing with a control mechanism that the pilot will be able to use to hopefully glide this thing a really far distance. So this is it right here. I want to go ahead and thank everyone for following us on Facebook, for your continued support. Hang in there, we got some exciting stuff coming up, especially that Red Rock Rover benefit concert. Don't forget, that's this Sunday, August 11th. Log on to facebook.com/RedRockRovers for more information, and don't forget to come out, invite all your friends, and come out and rock out for a good cause. So this is it for now, man, and we'll update some stuff as it becomes available. Thank you so much, and we will look forward to seeing you on Sunday.